Hi guys, welcome to video 8E. This is the last of the required viewing videos for our two-dimensional area unit. And we're going to be talking about geometric probability in this section, and this is section 11.5 from your textbook. So the new vocabulary that we need here, first of all, is what is geometric probability? I'm going to start with the definition. That is the probability of a point being in some region, which we're going to call region B, if region B is part of a larger region, A. Okay, so that probability is probability of region B is always going to be calculated by taking an area ratio, and that's the area of the smaller region to the area of the larger region. So area of region B, that's the probability of landing in a certain area, whatever area they're asking you for, out of the area of A. And another way to think about the area of A is we could also think about this as the total area as well. There's not really a diagram that goes with that, so we're just going to scribble that right out. The next definition that we need is a sector. And a sector is a region of a circle that is bounded by a central angle. Remember, that's an angle that has its vertex at the center of a circle, and its intercepted arc, or in other words, the arc that is cutting off, the part of the circle that's cut off by the central angle. I like to call this, you guys, a pizza slice, because that's what it looks like to me. If we look at the definition, or excuse me, at the diagram here really quickly, the diagram for that is simply, here's a circle, there's a piece of it, this part. That's what we're talking about when we talk about a sector, okay? If you've ever played the board game Trivial Pursuit, this is one of those little wedges, although pizza slice I think makes a little bit more sense. So as we move to our next definition, and our last definition new for this section, it's kind of like sector, but it's not. It's related to it slightly, but it's called a segment, and this is not a line segment, okay? This is a segment of a circle. Make sure you know the difference. It's not just a line segment. But it is another region of a circle, and this region this time is bounded by the arc of the circle and a chord of the circle. So if we look at the definition there and how that relates to the diagram, if we had a central angle like so, and we had our chord, the segment would just be this part right here. So I've had students call it a fingernail. With the analogy that we just set up here with the pizza slice, I like to say that this is the pizza crust.
Mama, it's time to eat.
And if you just heard that little voice in the background, that was my daughter. So talking about pizza crust, she just called me to dinner. So I'm going to finish this definition and then I'll be back. This definition, if we're talking about finding the area, and we'll go back and find the area of a sector in a second as well. The area of the segment is going to be the area of the sector. Take out that triangle that you see in the middle. The area of the sector, let's go up and put that by our diagram here, is going to be equal to whatever the angle measure is of that central angle divided by the total degrees of the circle, which is 360, And we're going to take that fraction of the total area of the circle, which you know is pi r squared. So it's just a ratio of the angle out of 360 times the area of the circle. And then again, when we're talking about segment, we're going to take that sector area. So this whole sector we need to find first, and then subtract out the triangle that is not being used in the area total. Sector minus triangle. Alright, so example 2 is where we're going to start in this section, and we're going to be talking about finding the probability in this sector. And we're going to find first the area of the blue sector, and then we're going to find the probability that if we were to like throw a dart at this dartboard, let's say, that it would land in the blue region. Okay, so first of all, the area of the sector, as we know, is just the same thing as the central angle divided by 360 times the area of the circle, which is pi r squared. Now we're told that the diameter of this circle is 12, so that means the radius is 6, and the blue sector has a central angle of 46 degrees, so 46 out of 360 is going to be multiplied by 36 pi, or pi times 6 squared. And when we go ahead and calculate that out, we get 14.45 units squared. So that's the first part, just find the area of the sector. Then, if I want to find the probability of getting in just the blue region, I'm going to take that number that I just came up with, 14.45, and I'm going to divide that by the total area of the circle, which is 36 pi. Also, please make sure that as you're doing this, if you get on your calculator and hit the divide sign after you get your 14.45, you know you're going to get answer divided by. Please make sure that you put in parentheses around what you're dividing by as far as the 36 pi goes. If you do not do that, you guys are going to get the wrong value for the probability, so make sure that those parentheses are there, okay? What we want to do is we want to make sure that we do that ratio, and we're going to get 0.13. And just so you know, that's also the same thing as 46 divided by 360, that 0.13. But do be aware, you guys, that that ratio, that simple shortcut of the central angle divided by 360, is only going to work for us in probability problems that involve sectors. Okay, it does not work for every single probability problem. So on the next page, the next example that we're going to be doing is not the probability of a sector, but this time a probability with a segment. So this time we're told, again, we have a regular hexagon inscribed inside of a circle, and so what we have is that hexagon is forming segments around the outside area of the hexagon. What we need to do is we need to first find the area of the darker shaded segment. If you're looking at the color video, that's the one in red. And then we're going to find the probability that a point, if we were to throw a dart, would land in that area. So if we were going to calculate the segment formula, remember, is that we first need to find the area of the sector and subtract out the triangle. So the sector, since we do have a regular hexagon, we know is 1/6 of the circle, because that central angle is a 60-degree angle out of 360. And with the measure that we have there, we know that the radius, if the diameter is 14 of that circle, the radius is 7. So we're going to be taking 60 out of 360 times 49 pi. Then we need to figure out what are the dimensions of this triangle here. So if we zoom in on the triangle here real quick, we know that because it is an equilateral triangle because of that central angle, then if we were to draw in a height to figure out the height of the triangle, we've got a 30, 60, 90 triangle on our hands. And so since the radius is 7, that's the hypotenuse, so my short leg is 3.5, and my long leg is 0.5 radical. So as we go back to our area formula, the triangle area is going to be 7, the base, times 3.5 radical 3, and then divide by 2. So if I calculate on my calculator the simplification of this whole expression, 60 over 360 times 49 pi, and then subtract out 7 times 3.5 radical 3 over 2, we're going to get approximately 4.439 if we find the area there. And again, that's going to be in units squared. Now if I want to know the probability of just having it land in that one segment, we're going to take that 4.439 that we just came up with, and we're going to divide it by, and again, make sure you have those parentheses as you hit your divide sign on your calculator. We're going to divide by the total area of the circle, which this time is 49 pi. And when we do that, we're going to get approximately 0.03, which means we have about a 3% chance of the dart, if you will, landing in the red region here. So that's the end of our video. Make sure you go ahead and do the 2 on your own examples, and I'll see you guys tomorrow.